Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're going to talk about Raspberry Pi 4. So let's dive right into it. Now, first thing you have to understand, Raspberry Pi caused a revolution when it was launched in 2013. Now, Raspberry Pi is not a computer. It's not like Xbox or Apple. It's not a computer. It's a tool. It's something that you use to learn more things. So it was very community powered. So everything about it, from the hardware, basically they will not ask you to license it. If you want to make a product using Raspberry Pi, you could do that. They will not ask you for licensing. So everything was open source, from the software which was using Linux distribution specifically made for it, and it was also open source, so everybody was fixing it. So over time, like as in over years, it became a big revolution. Like it became really big, and it started expanding. Now it expanded to a point where universities and colleges started to buy like 5,000 or 6,000 of them sometimes, and they bought something like this, basically a server rack where you have that like 5,000 or 6,000 Raspberry Pi. Question is why? Think of it this way: if you are running a computer university, you at some point in time you have to teach about supercomputers. Now at some point in time you will learn about supercomputers that they run on parallelization. Basically you will have same hundreds of things. Basically let's say you have running Threadripper, you're gonna have 10,000 Threadripper. That's how our modern supercomputers are made. Basically they have off-the-shelf part, everything about them. Other than GPUs, most of the processors are literally server grade or basically market bought. You can buy them, but you have to buy thousands of them. Now that cannot be done with computer hardware. It's way too expensive. However, Raspberry Pi, because the maximum cost was like $35, you can easily buy hundreds of them, and the power consumption was low enough so you can actually power it without requiring a giant server level power supply. So using this, you can give people a hands-on approach, how to code something, how to actually write a program that can utilize this kind of multi-core processors. So this was a really useful tool for university and college, and this was this took off. Basically everybody was building their own things and doing things and actually learning. This was much better than doing it in a simulator, doing it some kind of emulator. This was real, because if you have this many things, you will understand how hard it is to network sync, how hard it is to make sure the clock of every computer is the same. These are real things. So this became a very big episode. Many industry also started to make enclosures, like a very tiny enclosure that was put in DIN rails for industrial cabinets. So basically they will put it there and it will act as a data catalog. They will connect it with whatever. Sometimes they will make their custom systems, because it also has a general purpose input output pin. So they will make their own thing and catalog it. That's a very useful tool for industrial like this GeoIP. Using this, they can catalog data, which is really handy for in industrial environments. And maker community, they just ran with it. So this became a very big thing. Now if you want to understand more about how the heck this became this big, you can check my detailed video about Raspberry Revolution. So this was the foundation of it. However, there was some serious limitation because it was old technology. The fact they wanted to keep the cost down, asked them to basically it forced them to use old products, basically old processor, old architecture. Everything was old. Now it was cheap, but it was old, which means it was very limited. So biggest limitation was even though they had quote unquote gigabit in Ethernet port, it was not running at gigabit, simply because the gigabit was not directly talking to the processor. It had to go through USB bus. Now USB bus was USB 2.0, so the maximum speed somebody ever got was 300 Mbps. Now 300 Mbps is not very fast for internet, but if you are doing anything local array, like a local network can easily exceed this kind of speed. That's only 37 Mbps. Basically I'm if I try to directly copy my camera's SD card, that goes up to 90 Mbps. So you can understand this, this speed was a very big limitation. So that limited the network ability of this. Even though quote unquote it has gigabit, it just was talking to USB bus. And then USB bus itself, even though it was they had multiple versions till this point, they never upgraded the USB 2.0. So USB 2.0 was the choke point. You can't really do much with USB 2.0. Even mechanical hard drive spins faster than USB 2.0. So you have to understand this. USB 2.0 was the final limitation. Now when it was launched, the fact that it could do full HD was mind-boggling. This was in 2013, full HD for $35. That was amazing. People were thinking about making everything from YouTube downloader to media players and all that. Now at this point in time, full HD is okay, full HD is okay. You have to understand, at that time, if you wanted to buy a full HD mobile phone, that was flat out not possible. So at that time it was very high tech, but soon it became very obsolete. Then the fact it has only 1 GB of RAM, and that was in the latest version, because if you go early back, the RAM was only 256 MB. So that was not enough. Even though if you had processors that were like, able to compile a lot of data, it was not simply fed. The processor was running idle simply because the RAM did not have enough bandwidth. Like RAM did not have enough data to feed the processor. So that also caused a choke point. So early days, because it was such a good media player, people wanted to make network attached storage. They could not, because everything was limited. Everything was limited to USB bus, and the fact that Ethernet is not powerful enough for, like I told you, like even my camera SD card can outperform this thing. So that was the old limitation for their idea of using old technology to keep the price down. But this time in Raspberry Pi 4 Model B, they thrown it all out of the window. They are simply like, okay, let's go back to the root, redesign it from ground up. This time they are using something latest. Now, how can they afford to do that? Well, they are big now. They can actually mass order things. They don't have to be like, okay, we do not know how many units gonna sold. They know, like they have reach. Now they can do a very high-end processor for very low price. So they are pushing this architecture, single board computer architecture, to the maximum. So first thing they did, they basically upgraded from 2 ampere circuitry to 3 ampere circuitry. So you need a very powerful USB-C power brick to run this, and it will become apparent why they did that. Is basically now they have quad core Cortex 72 architecture based basically processors, and it's running at 1.5 gigahertz. That's good. Like that's good. Like that's powerful enough for like a proper mid-range smartphone. Like that's powerful. That's not something that you can just it does not do anything. I can barely do web browsing, barely can run the 480p videos for YouTube. No, that can do things. Like that is powerful enough to do things. On top of that, this time, because they have such a powerful processor, they also made sure that you have RAM options. Now be aware, 1 GB is gonna cost you $35. That is their $35 target. They never want to exceed that. But if you want to go higher, you have to spend $10. You want to go even higher, you have to spend $10 more. So $55 will give you 4 GB low power DDR4 RAM. So that's amazingly high end. Like in terms of RAM modules, like this is the latest ingredient. Of course, if you buy for, let's say, OnePlus or Samsung, they will be pushing it. Like their RAM modules will be working much higher. But this is really good. Like this is not corner cutting. This is like high quality RAM. Then because now 4K is becoming a thing, so you need a codec that can handle 4K. So older codec was H.264. Now H.264 is a very good. It does gets the job done, and they had a dedicated codecs engine, basically a sort of a dedicated video decoder that can handle that. Now they have a dedicated video decoder that can handle H.265. H.265 is still new. Basically, at this point in time, very few things can actually do H.265 properly. Like your computer can do it because it has more than enough horsepower. But if you are talking about media players, very few can do that. This can do that. Like many smart TV simply flat out reject the H.265 video files. So you have to understand that this is a big thing. The H.265 codecs is complicated. Using a dedicated processor for it will like solve the problem. So they're pushing it. This time Raspberry Pi is not like holding back, okay, I'm using from like 2008 technology. This time they're pushing it ahead, and they can do upwards of 4K 60 frame per second on single monitor. And if you can notice it, like they have HDMI 1 and HDMI 2 micro HDMI port, they can do HDMI 4K 30 frame per second on 2 monitors. So that is a very significant thing. Now you might be wondering why the heck a single board computer needs dual display output. The sole reason for this is basically for kiosk operator. Many people wanted to use Raspberry Pi for kiosk, but they could not because the display output was the same. So the idea is basically you'll have one monitor that is like when you see in the McDonald's, basically one person has a menu where they are selecting what they want, another person is adding up the cost or like what you want or like order code and all that. So for kiosk operation, this kind of useful thing, it's very useful. For some sort of arcade consoles, these are also useful. So it is really useful, and it was demanded by the community. That is why it's there. It's not like, okay, they just thought it looked cool. They have the processor that they can run it. Like 4K 30 frame per second is still a big deal. Very few TVs can do that. Cheap TV, expensive TV can do that. Cheap TV, I'm talking about cheap TV. I'm a poor guy, so think about that. And then the final limitation they broke is now they're using USB 3.0 circuitry, and their real world benchmark can go upwards of 500 Mbps. That's fast enough that no mechanical hard drive can outsmart it. Of course, SSD can still outperform it, but no mechanical hard drive can do this, because you can notice it has USB 3. And you can see this time they have LED lights on their gigabit port, because it's a true gigabit port. Basically, you can transfer data at upwards of like 900 MB small b PS. Basically, that's you can touch a very high speed. If you are directly transferring from RAM, you can touch high speed. So for practical reason, because even if you are transferring at very high speed, it won't go anywhere, because where will you put it unless you're putting it in a RAM disk? So you can go get upwards of 300 Mbps, because that's the limitation from USB 3. So that's a very good thing. That's good enough that you can have two mechanical hard drive running a dedicated NAS with useful speed, with usable performance. So basically this can be allowed to like breathe. Now because of there is more RAM in this, and now there the whole ecosystem is matured, you can even get what we call as power over Ethernet. Now, power over Ethernet, there is a hat that you have to buy that will allow you to directly extract power from the Ethernet itself. Given the power level of this thing, like how much things it can do, the amount of processing power it has, it's a really useful tool. So what would be the outcome of this? Now think of it this way, this will give very big boost for media, because even though that's the first thing people wanted to build, like the moment Raspberry Pi came out, like the first thing, other than making actual circuitry and robots and all that, the other thing that people thought of was making a dedicated media center. Now it is very suitable for that. However, the limitations of secondary things, like the fact that you can't stream to multiple people, because simply you don't have the bandwidth. Basically your hard drive can't feed 5-6 HD video to other people, simply because the USB 2 is the choke point. And on top of that, even though let's say somehow you figured out how to bypass that choke point, the processor was not faster. Even if let's say you somehow overclocked it, yes, people overclocked it, people liquid cooled it, so let's say you bypass that limitation, then the RAM was limitation. Now they have a completely new architecture which is like powerful enough to do all these things. So it will give a very big boost, and given the fact there is so many distributions specifically built for a media server, it will be a really big blessing to have such a powerful hardware that they can actually use it. Like this can make a very good basically media PC, a very good caliber one. Basically you can have connected to directly Ethernet to your network internet, and stream data directly from home, and you can even download videos in the background because it's powerful enough for that. So it's gonna give a very big boost in media. Then everybody wanted to make network attached storage out of this, because network attached storage is like kind of very odd place, because even if you buy a very cheap low end one, it's way too expensive. Basically hard drive is not the expensive part, the case is. Now again, if the case had magical properties, or like it was like a latest and greatest, it can do 8K and all that, it could not do that because it was low volume product, so it was very expensive. People wanted to use this, but it failed simply because the USB 2 choke point is so slow that even your mechanical hard drive can outperform it. Now you don't have to worry about that, so network attached storage will get a big boost. And given the fact that you don't have to worry about your Ethernet being choked, that's also a big selling point. So network attached storage and media system will get a very big boost. Like I am reasonably certain by the end of 2019, basically at the early 2020s, like there would be at least 2 to 3 Kickstarter about making network attached storage using this. I can guarantee you that. Then if you go to the Raspberry website, and they are selling it as a basic, very low end basic PC. Is it that? Short answer, yes. It's like at this point in time, yes. Like for let's say people who are just doing for inventory management, all you do is just punch in data in a spreadsheet. This puppy can easily handle it. All you do is like kiosk management, this puppy can handle it. And all you do is like web browsing, like if you are a retired person, let's say you are retired and you're just like, hey, I just want to like chill out, do some tweets, and nothing serious. Don't go about like, okay, I'm gonna do 4K video editing. No, just no. Simple, chill out. This can handle it. So that also allows it as a very useful tool for students. Like you can give them, okay, this is a computer. Now you utilize the GeoIP pin, because the processor that is backing it is so powerful. You can do advanced coding. You can do a lot more things. You can make smarter appliances. So it has a really large potential for outcome. Now the first thing I can easily guarantee you, I can like put my money down that network attached storage and media player is the first thing that's gonna flood the market by 2020. So I can guarantee you that. However, the basic home PC, I think they still need to bit more. They have to push it bit more, next generation, bit more, because to USB 3.0 is limited, and the final limitation, please be aware of it, is still relies on SD card. Now the biggest problem with that is like people have tried to bypass it, like you should not use SD card as a OS program, because OS will wear it out. So many people are saying even high quality SanDisk or Samsung cards, they barely last for 6 months. That is a limiting factor. So even though you can connect SSD through USB, the operating system does not want to go there. So there are some way to bypass it, brick the basically the distribution to like, okay, force it to go through USB system. Now if because this is very early on, I'm talking about a video which is very early on, if they have addressed that problem, awesome. That means you can actually use a high level pen drive or basically flat out old SSD. because SSD is gonna last much longer than a micro SD, because micro SD people were saying like if they were continuously using it, 6 months tops, like 6 months maximum. So if you're making a network attached storage, you don't want to have like okay a 5-6 micro SD card. Like okay, so that is a limitation. So be aware of that. So I'm not sure whether they have fixed it or not. So this was my presentation about Raspberry Pi 4. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And please leave a comment because I reply to all of them. And subscribe, press the bell icon if you're free. And as always, watch all my other videos also. And as always, thanks for watching.